All right, so I've got a little confession to make. Sometimes, even today, I use my fingers to do math. And you know what? I'm not even a little bit ashamed of it. In fact, today I'm going to show you exactly why you shouldn't be either. Because hidden on our very own hands is a tool so cool, so elegant, it's basically magic.
It's a question I get all the time from parents and teachers. We've all seen it, right? A kid who's definitely old enough to have their times tables memorized, and they're under the desk, subtly counting on their fingers, and that little voice pops into our head like, isn't that a crutch? Shouldn't they be past that by now? It's a fair question, but maybe it's the wrong one.
I love this comeback because it just flips the whole debate on its head. I mean, think about it. Do professional pianists use their fingers? Of course they do. Their fingers are these incredibly sophisticated, highly trained instruments. So what if we started thinking about finger math the same way? Not as a crutch, but as a really powerful tool.
Okay, to show you what I mean, we're going to dive into a beautiful little piece of finger math that honestly feels like a straight-up magic trick. This is the 9 times trick. And I'm serious. If you can, put down whatever you're doing and try this along with me. You won't regret it.
All right, you ready? Get both hands out in front of you, palms facing down. Now just imagine your fingers are numbered 1 to 10, starting with your left pinky as number 1 and going all the way across to your right pinky as number 10. The setup is that simple, but the payoff? Oh, it's good. So let's try an example together. Let's do 4 times 9. First, we've got to find our 4th finger. So left pinky is 1, ring finger is 2, middle finger is 3. There it is. The left index finger is number 4. Now, all you have to do is fold that finger down and just look at your hands. That one simple move has just split all your other fingers into 2 very obvious groups.
And bam, the answer is just laid out right there for you. Look at the fingers to the left of that folded down one. How many do you see? 3, right? That's your tens digit. Now, look at the fingers to the right. How many are there? 6. That's your ones digit. You put them together, 3 and a 6, 36. It works every single time. It's perfect.
Okay, that feels pretty amazing, right? But this isn't a magic show. We're here to explain things. So it is time to pull back the curtain, because behind this awesome trick is an even more awesome mathematical truth.
Here's the thing. What's happening on your hands isn't some shortcut around the math. It's a physical performance of the math. Your fingers are literally acting out a deep truth about our number system. They're running a little program based on one of the most important ideas in all of math, place value. Let's prove it. Okay, let's stick with our example, 4 times 9. We can all agree that 4 groups of 9 is just, it's 3 groups of 9 with 1 extra 9 tacked on at the end, right? That's just a basic math fact. 3 times 9 plus 9.
Now think back to your hands. The 3 fingers on the left, they stood for the tens digit, right? For 30. So mathematically, how do we get 3 9s to become 3 10s? Well, each one of those 9s needs to grab a 1 from somewhere to become a 10. And where can we get 3 1s from? Well, look at that. We have that extra 9 just sitting there, waiting. So we just break that last 9 apart. We borrow 3 from it, and we give 1 to each of our other 3 9s. Now what's left over from that 9 after we took 3 away? A 6. So our equation now looks like this. 3 times 9 plus 3, and then that leftover 6. Does that look familiar at all? 3 and 6? And there it is. That first part, the 3 times 9 plus 3, becomes 3 times 10. So the whole thing is just 3 times 10 plus 6. 3 10s and 6 1s, 36. The 3 fingers to the left of your folded finger are the 3 10s. The 6 fingers to the right are the 6 1s. It's a perfect physical model of place value in action. Now what's so cool about this is that it isn't just a one-off thing for the number 4. This logic works for any single-digit number, and we can actually prove it by going from this one example to a universal rule, a simple and really beautiful algebraic formula. Let's just walk through this nice and slow. Let's say any number we want to multiply by 9 is called w. So in our example, w is 4. Okay, look at the slide. The number of fingers to the left, that's our tens digit, it's always 1 less than the number we started with. So w minus 1. For us, that was 4 minus 1, which is 3. And the fingers to the right, that's just whatever's left. It's always 10 minus w. For us, 10 minus 4 is 6. And that leads us to this beautiful universal formula right here. It shows that to multiply any number w by 9, you just take 1 less than that number, multiply it by 10, and then add whatever 10 minus w is. You see? This is not a trick.
It is a physical embodiment of an algebraic identity. Your hands know algebra. How cool is that?
So, this brings us right back around to where we started. Back to that student counting on their fingers. Why does any of this matter? Well, it matters because when we just dismiss this stuff as a crutch, we are missing the entire beautiful point.
We really have to redefine how we see this. It isn't a sign of weakness at all. It's a physical bridge. It connects the concrete world that a kid understands, their own two hands, to the very abstract world of mathematical ideas. It's a way for them to literally touch and feel the logic of how numbers work. So what's the big takeaway here? First, finger math is a tool, not a trick. It uncovers these amazing hidden patterns in numbers, and most importantly, it gives us a reason to ask why. Why does this work? It transforms what looks like a simple shortcut into this deep, hands-on lesson on place value.
I just love this metaphor. You know when you see a building being built, you could look at all that scaffolding and just see it as a temporary mess that's going to get torn down. But the builder, the architect, they know that scaffold is absolutely essential. It's the structure that lets them build higher and higher. Finger math is that scaffold. It's the support that lets a learner build this magnificent, towering understanding of math. And that really just leaves us with one last kind of tantalizing thought. If a deep algebraic truth like this is hiding on the backs of our own hands, just imagine what other elegant, beautiful mathematical secrets are out there, just waiting for us to find them in the most ordinary places. Go find them.